Alright guys, so in this video you're going to need to make sure that you print this sheet out. That's on the blog. It's right next to the video. You can click on that, print this out. If your printer does not work, you need to have mommy or daddy email me and let me know. Otherwise, you need to copy this down. So we are going to take the equation of the circle, what I gave you on the note card, and we're going to prove it by the distance formula. So we need to make sure we remember what the distance formula is. Alright, so if you remember the distance formula right here, where I'm basically going to subtract some x's from each other, square that result, subtract the y's from each other, square that result, and we're going to add those two things together, and we're going to take the square root to figure out what that distance actually is. Well, before we do anything, what I want to do is we're going to start at the origin. So I'm going to have a point right there on the origin, and I want to choose some point on this circle. Now I'm going to focus on the first quadrant because my points are positive. So I'm going to choose a point. Let's say I choose this point here. We're going to call it point P, to be real creative, P for point. And then I'm going to draw a line that connects those 2 points. And what I want to do is use the distance formula from the point that we have here and this point that we don't know, but it's in the first quadrant. So things that we do know. This point here we know is 0, 0. But what we don't know is this point here. We have no clue. All I know is positive. So all I really know is it's going to be some point x, or some number x, and some number y. I have no idea what those numbers are, so we're going to let it represent just x comma y. Now, I could have chose to make this line in the second quadrant if I wanted to, then it would be negative x comma y. I could have chose a point down here and have the radius, but then it would be negative x, negative y. So I wanted to make sure both of my points are positive. Now, what I need to do next is the following. Since my pieces up here have x2 and x1, y2 and y1, I need to identify these values that I have here in terms of x1 and x2, y1 and y2. So let's suppose that I let this point be x1, and that point be y1, and then we're going to let this be x2 and y2. Okay, so by using those two values, I'm going to take the things I have in blue and I'm going to plug them into this equation. Because what I did right here is I took the values of x1 and x2, and I'm going to plug it into this formula of x2 minus x1. So that would be x2x, x1, 0. So all I did was take what I replaced and I put it in the same spots. Then I did the same thing for y2, which is y, and y1, which is 0, and I plugged those pieces into my formula. Well, then I took it one step further and I noticed, well, x minus 0 is just x, so this is basically x squared. So all of that just simplifies to that. And then all of this, y minus 0, is the same thing as y, but I'm squaring that result. Now, the distance between this point and that point, that's the distance, but this is the radius. So I'm going to put an R for the radius, which means instead of d equals, we can really say R is equal to the square root of x squared plus y squared. Well, now what I want to do is get rid of this radical, because if you remember in the proof, there was no radical to begin with. So what I want to do now is, since this is a square root, we go backwards. Since it's a square root, I'm going to raise both sides to the second power. It's basically whatever my index is. That, remember, if you remember, recall that it's understood to be a little 2 right here. And so since this is a square root, we square both sides. Well, this becomes r squared, and when you square a radical, that means now the radical disappears and it's x squared plus y squared, and here is the equation of a circle done, the proof by the distance formula. So again, I wanted to show you where that came from. Don't want to just give you an equation without kind of showing you where it originated from. All right, guys, so down here on the bottom here we have the Pythagorean theorem. And again, the proof by the Pythagorean theorem is going to be much faster than what we did above. So what I want to talk about is the Pythagorean theorem. You might remember what it is. All right, so the Pythagorean theorem, remember, a squared plus b squared equals c squared. Remember, the Pythagorean theorem is dealing with right triangles. So that's the deal that we got to remember. Well, there's no triangle anywhere in the circle. So what we're going to do, very similar to what we did above, we're going to start at the origin. And we're going to choose a point, again, in the first quadrant. I could choose any point on the circle. I just want to deal with positive numbers. And so we're going to extend our line to that point, which basically that's my radius. And again, this is some point. I don't know what that point is. So we go ahead and label everything that we know. We remember this is 0, 0, and this is some point x and y. Well, since we're talking about the Pythagorean theorem, we want to turn this into a right triangle. Well, what I'm going to do is take that point that's on the circle, and I'm going to drop a line straight down to the x-axis. And you're going to be using right triangle trigonometry when you get to your next class, but here's a little preview for something you're going to see later on down the road. Well, when I drop that line straight down, that creates a right angle. Now we have a right triangle. Well, the next thing I got to do is to identify, since we're going to do the Pythagorean theorem, I already know that this side is r. The question is, what is this side, vertical side, going to be, and what is this horizontal side going to be? Well, to go from this point to get to this point, I have to go over so many units and then up so many units. Well, I don't know what this point is. All I know is it's x comma y. Well, to get to this point, I would go over x units, whatever that is, and then I would go up y units, whatever that is. Well, since I don't know what they are, we're going to say that this horizontal side is just x units, and we're going to say this vertical side is just y units. Now, in the Pythagorean theorem, I need three sides of a triangle. Well, I've got this horizontal side, I've got this vertical side, and I also have the hypotenuse side. This is awesome because I already know three sides of my right triangle, so what I'm going to do is to use these values of x, y, and r and plug them in to the Pythagorean theorem. So when I do that, my side x and my side y are just like my a's and b's. So therefore I would have x squared, one of my sides of the triangle, plus the other side of the triangle is equal to c, which is the hypotenuse, but I know the hypotenuse is r. Well, I have x squared plus y squared equals r squared, and look at that. That proof was so much faster than the distance formula. So guys, we are going to do a lot of right triangle stuff to help us with the problems on that worksheet that was stapled that I gave to you that I said not to worry about on the weekend. So we're going to do two things, mainly right triangle stuff, but we're also going to have to remember how to do this distance formula to help us out with some other problems. So I wanted you to see this real quick. On Monday, we rock and roll with conics, talking about the circle.